Okay, this little revision of equilibrium, I'm going to divide this into 4 different parts with my book, whatever the content of the book, because if I just continue only with this revision, you would be bored and you would feel sleepy because knot is really huge. A steady state, 2 different directions and both directions are same. We don't want that part. This water tank, this O2 percentage, or this candle thingy, we did that. Manu, I don't know, like when you don't have the knot with you, this knot. Yeah, but still, I guess if you're not understanding me, just disturb me, okay? But then the dynamic equilibrium is the most important part that we are always going with this equilibrium condition, always the closed system, and rigid mean the volume is constant. Then here I will explain the forward reaction, backward reaction. When the reaction rates are equal, that's achieved equilibrium. Then this is the little summarization. Equilibrium, this all these macroscopic properties are changing. Sorry, microscopic properties are changing, but macroscopic properties are same. Number of moles, mole fractions, concentration, pressure, and temperature. Also, all those parts are here I'm explaining. And this is a summarization that we have 4 different categories. I'm not going to go through that. Then start in the chemical equilibrium. This actually is the base of equilibrium, the chemical equilibrium part. If you have the equilibrium chemical reaction, that is chemical equilibrium, write the rate expression for forward reaction and backward reaction separately, and see whenever they are asking you guys to prove giving these rate constants, you're supposed to get this equilibrium constant by rate constant. Memorize that. We have maybe 1 or 2 like very rarely questions, but that is the possible part because they were not asking these questions. Anyway, raise into the stoichiometric coefficients. Here, stoichiometric coefficients of products and reactants. That ratio is the equilibrium constant. Equilibrium constant can be changed only by changing what? Temperature, only by changing temperature, and units depending on the stoichiometric coefficient. Unit depends on stoichiometric coefficients. Equilibrium law, you know that I just explained. Then with respect to pressure, you can just say the same thing. Instead of concentration, you can use the pressure. Then we define the Kp, exactly same rules. Then writing Kp and Kc expressions. Then getting this number of reactants and product molecules, you can write the units. Here again, I'm explaining this little thingy. When you are considering a standard condition means whatever the standard concentration or standard pressure. So we are dividing each of these terms by that standard condition. Each of these, see ammonia, nitrogen, and water, you are dividing each of these by standard pressure. Then you are cancelling off same units. So when you are considering the standard condition, Kp or even Kc is unit less. That part they were not added so far. So I don't know how they can ask such questions. Okay, then the relationship between Kp and Kc, you are writing the Kp, Kc expression separately. Then instead of concentration, we can write these concentration using pressure terms. Then substitute it to Kp. Then you can get this connection Kp equals Kcrt delta N. I keep saying this, delta N is this balancing coefficient, and they are always giving a couple of marks for this one. So you have to show how you get this one. Product minus reactants. Okay, that's to explain that thingy. Then again, this little thing I'm using, whenever there is this solid something, solid concentrations are considering as constants. And that is called derived equilibrium constant. Sometimes that can happen even when you are using the medium as the reactant, because medium is concentration is really high. So this changing or the decrease in the concentration is very low. So you again, not only the solid, but also medium is using as a reactant, we consider that concentration as constant. Okay, those are to understand that part. Le principle, you guys know that whenever you are doing a disturbance, to rearrange this equilibrium system to minimize this disturbance, you can explain using the concentration, temperature, pressure, and volume. Using the word le always giving you marks. Whenever you are saying disturbance, according to le principle, it is going to left or right. They are giving marks. Okay, I'm not going to explain all these. This one came, I guess, in 2021 or 22. They were asking something with this. If they were given this kind of a graph, you just need to check this. See the gradually decreasing, gradually increasing. But from here to here, instant increasement. Whatever you have added instantly supposed to be added here. So what is that? H2 gas. So then consider it is reactant or product. If it is reactant, to decrease, this is going to forward. Or if it's a product, to decrease, it is going to backward. Okay, that is the part you're supposed to think. Whatever the increasing concentration, going to the other way around. Okay, even when we were writing this, I was feeling a little frustrated because in resource book, they have added all these examples, so I couldn't care less. So I have added everything. Almost all these are came through this inorganic chemistry. You are supposed to go through that. Temperature going with exothermic and endothermic. Exothermic mean you are exothermic. You are heating up. So when you heat, then reaction is going to backward and so on. That's all I'm just saying. And these equations, plus or minus, they were expecting you to memorize all those. So they were asking this, and now we know they were asking about this thingy. Only this one they were asked so far that they think you're supposed to memorize whether it's exothermic or endothermic. But then next time if they ask another something, you're supposed to have the memory, okay? They would ask about this because now they know you know this one. They would always try to find something that you would feel, okay. Pressure and volume, that's again depending on the number of moles. Pressure is proportional to number of moles. When you increase pressure, mean you are increasing number of moles. So reaction is going to the direction to decrease number of moles, that is to decrease pressure. So that volume is opposite of that. Okay, rate time with reactants. This is again connected to kinetics. So the product with time increasing, reactant with time decreasing. Now they are reaching this equilibrium condition. Rate supposed to be equal for forward and backward. If you go with normal reaction, irreversible reaction, so one product concentration is continuously decreasing, reactant concentration is continuously increasing. But for reversible reactions, concentrations become constant after a particular time. Maybe both concentrations become equal, or maybe reactant is still high, or maybe product is still high. Okay, so if both are equal, KPKC is supposed to be equal to 1. If the product is high, KPKC is greater than 1. Product is low, KPKC less than 1. Are you understanding? Okay, even if you had little excess of reactant product in the medium, that product is not still enough to go backward to make reactant. Then still, both forward and backward reactions are starting. So the backward reaction, since it is not started, even if you add little amount of product, so you're going to start from the 0. Clear that? Because still backward reaction is not starting because that concentration is not enough. But then if you go with the concentration, concentration can be not start from 0. If you add little excess of B, say little excess of B, it is starting above the 0. Hear that? And stop picking your beautiful skin. Okay, most important part. This is explain everything of equilibrium, that the principle of equilibrium. I guess you guys got this knowledge really nicely and neatly. Two different words we need, definitions we need. dissociation coefficient and dissociation amount. Coefficient alpha, amount x. Coefficient, how much dissociate from 1 mole. Amount, total dissociation. Clear that? Okay, I'm not going to go through the rest of the part. Dissociation percentage. Again, for calculations, we need this Dalton-Stokes partial pressure. Okay, this simple calculation I'm going to go with. So they are saying initial concentration is, initial number of mole is, this here part, I know, this always disturbing. I'm hiding it here, but it is coming back. I'm disturbing. Okay, initial number of mole is 0.1 and pressure is P. Dissociation coefficient is alpha. Okay, Manu. Now they are asking to find us Kp. To find Kp, we need partial pressures. If you write the equation, to find partial pressure, we need total pressure, that is P, and molar fractions. But to get molar fractions, we need, let's say I, so we need Ni divided by N total. We need number of considering moles divided by number of total moles. So that we need to find how much moles presenting at equilibrium condition. So this is where we apply only this little thing. We need the equilibrium principles. Rest of the part is normal. We need 4 calculations. So the initial is 0.1 per mole. Let's say alpha is dissociating, so that the remaining per mole become 1 minus alpha. So this is per mole thingy. This is per mole thingy, alpha, alpha, and 1 minus alpha. But we don't have 1 mole. We have, let's say we have 2 moles, so multiplying by 2. 5 moles, 5 multiplying by 5. But we have 0.1, so that we are multiplying with 0.1. Understood? So that, then simplify, get the total number of moles. Then each moles divided by total number of moles is the molar fraction. Multiply each with total pressure gives the partial pressure. Now we have expressions. You just substitute that, simplify, and get the answer. Understood? Manoj, I know these two are okay. I'm just asking you, anything you feel like uneasy with the principles of this dissociating part? No. Yeah. I guess your teacher, he is the one who said that passed away. No. What did you? Oh, okay. So you're comfortable. So how many teachers you went already? I'm the third one. So you one is that you, is your teacher the one who passed away? Then after that you went to you took both 2 classes. So are you ready? Okay here. Okay. Bandara Selangor kita tahu kini Anda ගියලු. අnder වැඩි කමට අම්මා කියවලු එනන් ඉන්නවා ගෙදර කියලා. You could survive. Oh really? Yes, I don't know. He's like some sort of a mental problem, I guess. When you get harassed, when you are a child, when you are in childhood, you do same things for others when you grow up. I don't have any other expression for that. Because you guys are really nice kids. In my classes, like there are lots of students, but nobody behave badly. I never had this single one thing. Now it's my time. If they are not stopping talking, then I'm just looking at them. I'm not doing anything. I'm just looking. Okay, ඔගොල්ලෝ කතා කරලා ඉවර වෙන්නකෝ. ඊට පස්සේ ක්ලාස් එක කරමු. කීයද 4:34. විනාඩි 6ක් කතා කරන්නකෝ. එතකොට මම 6:06ට ක්ලාස් එක අරින්නේ. I do that so that they just become so silent. I'm using little tricks, but never happens such thing. Okay, just a normal calculation, so I'm not explaining any of this. Aputa, if you want, if you feel like if you want to do this, these are little challenging, harder questions, but they did really nicely. you can ask them. There are this, the couple of pictures. So you can go through these questions and check your answers. Only very rarely they were given these calculations with symbols, but still they were given. It's not given. So we need the practice. That's all, I guess. Yeah, that's all. Yeah. Done with chemical equilibrium. Yeah, that's all with chemical equilibrium. Did you do the extent of reaction part? Yeah. Okay. How much to how much reaction is proceeding? First, I'm going here. Okay. Earlier for unit 5 that we know, when delta G is less than 0, that is spontaneous. When greater than 0, that is non-spontaneous. Then this is spontaneous mean reaction is going to forward direction. Forward direction mean, let's say B divided by A, that A goes to B. Forward direction mean B concentration is really, really high. It simply means equilibrium constant is supposed to be really high. So now we have two factors to consider this continuity. Not only LC is negative, but also K is really highly positive. Understood that? And these two you can understand. Then I'm moving on to this one here. If they were given this kind of a situation, just analyze the starting point and ending point. In between, so see, it is from here to here, it has decreased. Decrease means this is negative. So this is spontaneous. And again, if you analyze this point B, it is not favored more to product side, not favored more to reactant side. So this is in, like, the healthy equilibrium. And if you compare that one with these three, compare this point from here to here, here to here, and here to here, and also this equilibrium point. This is in good equilibrium, no reactant, no product, spontaneous. And this is also spontaneous, but closer more to products. But this is non-spontaneous, closer more to reactant. It simply means this is supposed to go to backward direction. Hear that? Might not disturb me, okay? That's all with that part. Then this little thingy, only thing you're supposed to remember is whenever they were given any concentration at any time, you can write the reaction quotient Q going with T here. Going with T here. Do the calculation. So far, only question they are asking, comparing this with the real equilibrium constant. So let's say Kc and Qc. If Kc equals Qc, both conditions are in one single equilibrium. Let's say A goes to B, then B concentration divided by A concentration. So Kc is greater mean what? Qc is less mean what? Comparing to A and B, Qc is less now. B is less. Less B in the medium. Understood? Less B in the medium. So reaction is supposed to go to which direction? To get B, reaction is supposed to go to increase B. Forward. It's to forward. So this is the condition that reaction is going to forward. Understood? Okay. If you understand that, I'm going to skip. This may be a little something is there that you can just continuously go with Q, but somehow, some way, there is this point of equilibrium. And if that is here, see this forward and this is backward. That's all with chemical equilibrium. Moving to ionic equilibrium, that all these are coming to ionic equilibrium. This is the longest and most complicated. We have a lot to learn in this one. Acid-base part, I'm just skipping. And just go through this a little, like just to compare these values. Just get this comparison idea. See, HF, this is inorganic acid. This is again inorganic acid. So Ka is greater. see the organic acid, even it's acidic, acidity is really, really low. And this is again inorganic acid, but see the acidity is really, really low. Just compare these compounds with their acid taste. I guess you have this. Yeah. Basicity is the same. Classification of acid base. Then these unit 3 questions. Loisier says there are metal oxides which are other than H plus, non-metal oxides. So non-metal oxides are releasing H pluses to the or give the acidic condition, but it's talking only about these compounds with oxygen, but there are acidic compounds without oxygen that fail behind. Arrhenius talks releasing of H plus and OH minus. That's again, he's talking about aqueous condition. That is one drawback. Then there are acids without H plus, bases without OH minus, so that it is failing. Larry Bronsters is the best one. He's only talking about H pluses, accepting H plus bases, releasing H plus acids. And then he talks about this conjugate acid and conjugate base. Conjugate mean you have a normal acid or base. Conjugate mean if that base is accepting H plus. Okay, that has extra H plus. So releasing that H plus is easier. So acting as conjugate. But base accepting H plus become conjugate. Acid and it is releasing H plus to the medium and vice versa. And also it can explain this self-ionization and relative acidity. Then this thingy I will explain when the conjugate base is stronger, acid is weaker. Clear that part. You understood everything really nicely when we were doing theory, so I'm not worrying too much. Then this one, anything, if anything is releasing acid to medium, H plus to medium or H2O plus to medium, so we are writing Ka. If anything releasing OH minus to the medium, we are writing Kb. For calculations, we need that knowledge. Then Oswald dilution law, this says when diluting more and more, dissociation increases, but concentration decreases because volume is also increasing. The Kb into C alpha squared, memorize these equations. Memorize these equations. For MCQs, you don't have to derive these. I am deriving during when we are doing a tutorial, but you have to memorize these so you can save huge time. That's why these students are going to 1.5 hours for MCQs. And these two, like OH minus concentration equals, you don't want any of these, you just need to memorize that one. Okay, then this is the very first question that we are doing with this Oswald dilution law. Okay, so far whenever we were doing any calculation, we were going with the normal calculation. Whatever the OH minus concentration is supposed to equal to whatever this base in the medium. But now the difference is Manoj, this is halfway dissociating. So that this concentration and this concentration are unequal. So we are going with equilibrium principles then. Let's say the X is dissociating, so the remaining becomes 0.125 minus X. Since it's releasing OH minus to the medium, we are writing Kb. I think I've given this knowledge really, really clearly because even weaker students of mine, they can answer equilibrium questions. So if you go really nicely with equilibrium, equilibrium is not a harder unit. Okay, so Kb, because OH minus, so I'm just writing this expression, no water. Then instead of these two, I can write X squared here. Instead of this ammonia, I'm writing this one. Then the Oswald dilution, this approximation, if Kb is really low, that we can forget this small x. Then 0.125 minus x become 0.125. Then you can cross multiply, then you can get the answer. Okay, Manoj. Finish. Are you guys tired? I guess not tired. Can you do the second book? Noni? Are you okay? Or are you sleepy? No? Seriously? Because I understood some students are getting sleepier with this because you are just listening, not doing anything. But I guess we finished the first book really fast. I guess I'm not worried because you guys having, oh, hang on, I don't have the second book with me. See this, even I've just got this from, today I did it when I came here. Yeah, so the same board here. So the same board. Okay, skip this to the next day. And I'm going to this.